So this is the scenario that you have in a plant, then it is transformed into the cities plant. Here we are going to have a scenario that this is the plant, it is stepped up first, then it transmitted to towns, cities, villages where the power is supposed to be used. So now we are going to use the step up transformer to step up the potential from 1000 to 100 volts to see what is going to happen, what is going to be the power loss if we step up the volt. So mm, the power plant is generating power at 1 megawatt. This is equals to 1 times 10 to 6 watts. Then we use the step up transformer here. It was generated at this one is generated at I is 1000 volts. Also the volts here was 1000 volts. As we calculated here, we find the current is this one, but the voltage was given to be 1000. Yeah, sorry, this is amps. Okay, so if we use the step up transformer, if we step this up, step up transformer say that Vs, V primary is equal to I is equal to Ns over Np. But we are not given the numbers here. What we are told is that if you use this step up transformer, we just go direct and get the voltage is transformed, is increased. If the voltage is increased, the voltage is increased from 1000 volts to 100,000 volts. So if it's from low to big, this is the step up transformer. If the new voltage is this one, what is the new current that is passing through the electrical wires? Again, from power is equal to IV. Remember that the transformer works under the principle of conservation of energy. The power is always conserved. If the voltage has changed from this number to this one, the current must go down. So here the power is still the same. The power is still the same because we are coming from the primary winding and then we are going to the secondary winding. So what we are saying that the power input is equal to the power output. Power from this point, it must be equal to this point if there are no losses in between. So the power is still the same. We have used the step-up transformer. The voltage has been changed from the input. It was 1000. Now at the output, the voltage is 100,000 volts. So voltage has increased. What we expect is that the current must go down. The power is the same. The power is still 1 million. The current we do not know. The new volt is this much. So if we are calculating for this I, we can divide by 100,000. This they cancels. Now we see the current is just 10 amps. Initially the current was 1000. Now the current has become 10. So if we increase the potential difference, then the current goes down. What happens now to the power loss? Power loss, again, power loss. Power depends on the current that flows through the wires times the resistance. Now the current that flows through the wire is just 10. You square this number times R, it is 0.5. This is going to be 100 times a half, you get 50 watts. This is better compared to this one. It is almost, if you divide those two numbers, this will cancel, it is 10,000 times. The power is saved 10,000 times compared to this one. This is much. So if it seems that whenever we increase the potential, the power loss goes down. This is the reason now I can answer this question, why electric power is transmitted at high voltages for long transmissions. The answer of the question is this one. To minimize the loss of electric power in the form of heat energy, because the power loss to the surrounding as heat strongly depend on the current, because the current is supposed to be squared. So if the current is big, is large, and you come to square that number, you can get a very huge number. So that's why we are using transformer to transform electric power from low potential to high potential, and then so that we can minimize the loss of energy as the form of heat. So just to conclude, this will be the conclusion of our lessons. We have an electric power plant. Then this, whenever the power is generated, we feed this one to step up transformer. Why are we doing so? So that we can minimize the losses of electric power in form of heat. Then we have these power lines. The power is now transmitted. Where before we get to the houses, for the domestic users, we use step down transformer. Also, in our homes, the voltage is about 2 volts to 240 volts. That enter into the main circuit. So after this one, it is stepped down to this value, then domestic use. So this transformer that we see in our neighborhood, it must be the step-down transformers because they are very close to our houses. So even inside our houses, what is happening is that you can see those mobile phone chargers. You have this is your charger, then you have some like this one. Here we have a transformer. Because those devices they have specific values of the voltage they are supposed to be charged. Even it is for the PC chargers, we see the same also. The charge of the PC is something like this one, then there is something here. There is a plug somewhere. So the transformers are not only that we see in our neighborhood, even inside our homes, we have transformers. So for some reason, sometimes we need to step up the voltage. Sometimes we need also to step down the voltages. Okay, so having said this one, this brings me to the end of the lesson.